In this video, we'll talk about finding the limit numerically, and in the next video, we'll talk about finding the limit graphically. So we use the numerical table to visually and correctly demonstrate how the function approaches the limit value from both sides. From both sides meaning from the left side and from the right side to a specific number. So we are approaching to a specific number, which is 2 here from the left side, and we are approaching to the specific number, which is 2 from the right side. So in such way we are reading the behavior of a function, okay, as x cannot be equal to 2, as we said before. So providing an intuitive understanding of the concept of limits before introducing algebraic methods. So let's see first example. What happens to f of x is equal to x to the power 3 minus 2x squared over x minus 2 when x is 2. So when x is equal to 2, f of 2 is equal to 2 to the power 3 minus 2 multiplied by 2 square over 2 minus 2 is equal to, so this will be 8, this is also 8, 8 minus 8 is 0 over 2 minus 2 is 0. So this is indeterminate quantity, right? So just a quick reminder, you remember we said for determinate quantity it is, for example, 4 divided by 2 is equal to 2. So if you multiply 2 by 2 you get 4. 4 divided by 2 you get 2. So in this case we call it determinate quantity. But in this case if we say 0 divided by 0 is equal to something, it can be 1, it can be 2, it can be 3, it can be 0, it can be minus 1, and so on, okay? So any number you multiply by 0 you will get 0 here, okay? And 0 divided by any number you get 0. So this is indeterminate quantity, and in such case we use limits to see limits to see the behavior of the function, okay? So let's see that. So when x is equal to 2, the function f of x is equal to x to the power 3, the same function, x to the power 3 minus 2x squared over x minus 2, okay? So this function results in the determinate form, as we said, 0 divided by 0. In such case, we use the concept of limits to analyze the behavior of the function as x approaches 2. So as x approaches to number 2, we'll see the behavior of our function, this function, okay? Okay. So by evaluating the limit, we can determine the value that the function approaches near this point. So as x approaches number 2, we will see that f of x also is approaching to a specific number, okay? So in this way, we will see that the behavior of our function, how it goes, okay? Even though the function itself is not defined at x is equal to 2, okay? So let's see this table. So when we plug this, so before to start with numbers, so this is x is approaching to number 2 from the left side, and here x is approaching to number 2 from the right side. You can think in this way, this is a line, okay? Here we have number 2, okay? So we are approaching from the right side, approaching, okay, but we never touch number 2, and we are approaching to number 2 also from the left side, okay, but we never touch number 2, okay? So we are doing the same here, and as x approaches to number 2 from the left and right side, f of x also is giving a value, okay? Is getting a value. So when we plug 1.9, so we, instead of x, we say 1.9 to the power, this is x to the power 3, so 0.9 to the power 3 minus 2, okay, 2 multiplied by x squared, so instead of x squared, 1.9 to the power 2 over 1.9 minus 2. So this is equal to 3.61. 3.61. Okay, so we do the same. So when we plug this value now, so this value now 1.99, we will get as f of x. So this is f of 1.9, right? So f of 1.99 is equal to, if we plug it into the function, okay, we will see that we will get x.9601, okay, 3.9601, okay, and so on, okay. So we'll see that at the end, as x approaches, so 1.9999, we are approaching really to number 2. We see that f of x also from the left side is approaching to number 4, okay. And we do the same for the right side. So as x approaches to number, so 2.1, 2.01, so it is approaching to number 2 from the right side. We see that f of x also is getting a value approaching or almost number 4. So as a result from that, we say, so we are reading the behavior of the function as we said, right? Because x cannot be equal to 2, right? Because we will get an undefined form. So that's why we are approaching to number 2, just to see how our function is behaving, the behavior of our function. So from that we conclude, so as limit x is approaching to number 2, from this minus means from the left side, okay, from here, okay. So we see that f of x is equal to 4, okay, the limit, okay. And as x is approaching from the right side to number 2, you see that f of x, the limit x approaches to number 2 from this plus means from the right side, f of x is equal to 4, okay. So since the limit from the left side is equal to the limit from the left side is equal to the limit from the right side, we say that, so the overall limit exists, okay, so our limit exists, and the limit x approaches to number 2, f of x is equal to 4, okay. So this is the idea in general. We are approaching to a specific number to see the behavior of our function, okay. So before to finish with this example, I would like to emphasize on this point. So this was our function, x is 2. So x is 2, you get the problem of 0 over 0, right? And this is indeterminate quantity. That's why we used limits to see the behavior of this function as x is approaching, okay? X is approaching to number 2 from left and right side. And finally, we saw that the limit of x approaches to number 2 of x is equal to 4. So this is important. We use the numerical table to visually and correctly demonstrate how the function approaches the limit value from both sides, left and right side, providing an intuitive understanding of the concept of limit before introducing algebraic methods like factorization. So I will just quickly, in the future we'll talk more about that, but just quickly to show you how to get 4 without using this table, because in the future you cannot use this table. Why? Because each time you should have a calculator to calculate that, okay. So f of x is equal to x to the power 3 minus 2 x squared. So we'll take x, so we'll use factorization method to find the limit. So we'll take x squared as a factor, comma, so f of x is equal to x squared multiplied by, so x to the power 3 will remain x because we took x to the power 2. Even if you multiply x to the power 2 multiplied by x, you will get x to the power 3. Okay, we didn't change anything. Minus 2. Okay, so we took x squared out, divided by x minus 2. So you see in this case, x to minus 2, x minus 2, they disappear. Okay, so you get x squared. Okay, so our function is now of x is equal to x squared. And now when x is 2, so now we replace instead of x 2, so this is equal to 2 squared, and this is equal to 4. So you can directly say, so the limit, or as x approaches to number 2, f of x, okay, is equal to 4. You see how fast was it? And you see here. So in the future we will use those rules. We will see some more rules also. Thank you for watching, and hope to see you in the next video with finding the limits graphically. Okay, see you.